Hello, welcome back to Piers Rocks. Last time around we took a look at this 2031 disk drive. This time around we're staying on the theme of 2031 disk drives. I'm going to look at this much more yellowed unit. In fact, this has another secret. So if we take a look at the rear of this 2031, we can see it's not a 2031 disk drive at all. It is in fact a 1541 in 2031 clothing. I suspect what happened here is the previous owner of this disk drive had it for use with a Commodore PET and then upgraded to a VIC-20 or Commodore 64 and wanted to reuse this disk drive with their new machine. Obviously the cases are very similar, it's the same drive mechanism, so the only thing that's really required to convert a 2031 to a 1541 is to replace the PCB. What I want to do today is convert this back into a real 2031, so I have a pair of them that I can use with my different machines. So that means really doing two things. First thing I need to do is check that this works as a 1541. I don't want to go to the trouble of converting it to a 2031, find it doesn't work. I want to fix any problems with it ahead of time. And then the second thing I need to do is actually convert it over to a 2031 and give it a new IEEE 488 port and all the necessary circuitry inside to do that. So if that sounds interesting, stick around, and first thing we'll do is open it up and take a look inside. Okay, so I've not looked in this 2031 before, so I don't know what to expect, but we can have a look together. Okay, so it's got the shorter board PCB in it. Check I'm not putting my head in underneath the camera. So what's that? A 1540050 PCB, I think. It's got everything I'd expect it to have: 6502. Double 6522s, that'll be the RAM, and the two ROMs. So I'm not quite sure what I'm looking at in terms of ROMs here. I'm not sure what the I think 901229-05 is the standard 1541 ROM. So to me this looks just like a stock 1541. We've even got the two jumpers to cut here to change the default device. We've got a few components a bit more bent over than I expect to see here. These bridge rectifiers I don't think should really be twisted over like this. A little bit dirty, but doesn't look too bad. Just having a look at the disc head. Disc head's a bit dirty, so we'll give that a clean. So first thing I'll do is get the multimeter, just check that the disc heads are working fine. We'll give the head a clean, and we'll just check that the mechanism is free and can be moved up and down. Otherwise I think I'll be ready to power it on. Actually, before I do that, I'll also just take the PCB off and have a quick look underneath, make sure there's nothing dubious underneath there. But let's get the multimeter and check the resistance of the various coils. We'll just check for a short across live and neutral. I don't fancy plugging in something that has a short across live and neutral, it'll make me jump. That's like 58 ohms or something. I'm not sure how well you saw that. So it's not a dead short, it's just the resistance of the coil windings on the transformer. It is actually turned on. We're turning off, we should get nothing. Yeah, we get nothing. So the fuse must be good, given that we're detecting the coil windings. So got no reason, I see no reason why not to power this on. So just before I power it on, I wanted to show you the underside of this board. So we've got very similar bodge wires to one of the two 1541s we looked at in the first episode, and the ROM chip has been reworked, but we knew that. because if we look at the other side, we saw that it had a socket put in. So I think what we're looking at when it comes to the ROM is the 24-pin ROM has been replaced with a 28-pin EEPROM, and there's just a couple of sockets there acting as converters. I don't see any need to change that at the moment. We will power this on, see what happens. Right, I have the 1541 in 2031 clothing hooked up to this Commodore 64, and I will turn it on. Sounds awful. Reset the C64. Good, it correctly resets. And let's have a look if we can contact the drive. We can contact the drive. So we get an error because there's no disk in the drive. We get the correct error code. I'm going to put in one of my scratch disks at this point because I'm not sure I want to put a decent disk into this drive given the terrible noise it's making. Not sure what's on this disk. Guess we'll find out. Okay, it can't read. So we're getting a read error, so we have some kind of failure on this drive. Next thing I'll do is install the World of Janny disk diagnostic cartridge and see if we can actually get anything out of this drive at all. For example, if the speed test works, and also to see if we get anything out of the alignment check. Okay, speed test first. Well, if that's actually the speed it's spinning at, then no wonder it can't read the disk. As a first step towards diagnosing the speed problem with this drive, I thought I would try adjusting the speed potentiometer. So I've got the drive out of the lower half of the case. If you're doing this, be careful. There's exposed live wiring here underneath the transformer. The speed potentiometer is located here on the disk drive. There's a little hole, and then you can get a small flat blade screwdriver in there. So we run a speed test. Every time I run a speed test, it's getting faster and faster. And if I actually adjust the pot, it doesn't seem to be making any difference. And here's a close-up of the drive itself. So the hole where the pot is located is here, and then this ring on the spindle motor, well, there's actually two rings. The inner ring should show a steady pattern at 50 Hertz, which is what I'm filming at, and then the outer one should show a steady pattern at 60 Hertz. And at least on the camera screen, I'm seeing a processing pattern on the internal ring, which does suggest that the speed of the drive is out. So my next plan is to look at the schematic describing how the motor is actually driven and attempts to achieve 300 RPM. You can see I've got two Alps drive mechanisms in front of me. The one on the left is from the drive that I'm currently repairing, and the one on the right is from a known good 1541, in fact one of the drives that I repaired in the first episode. So a few things that we can see immediately. The first is that the drive belt on this first Alps unit is actually around a screw that's been put into the mechanism here. I think because the belt itself is actually very, very loose. So if I do that, it's not going to drive it at all. It's incredibly slack now. So I think it's been put around this screw to increase tension. So I've ordered a new drive belt, which will take a while to get here. I think the squeaking or the noise I could hear when this drive operates is partly the belt going around this screw, and partly the fact that the motor is being driven much too fast, 400 plus RPM as we saw. Because these two drive mechanisms are the same, I can obviously swap in this working unit for the unit that isn't currently working and see if the drive works with this unit installed and there aren't any other problems with the drive. So that's what I'm going to do now. What I think might be the problem here is that the tachometer on the motor of this failing unit has failed. So if we turn this unit over, then the motor that drives the spindle is this one here, and the grey and the yellow wires that come out of it here carry an AC signal to the driver board on the underside of the unit here. That's rectified using some of these diodes here, passed into this IC here, and then this IC decides whether to drive the motor faster or slower based on the input it's getting. So I'm speculating that it's not driving the unit at the correct speed because it's not getting the signal in. So the other thing I can do, because I've got two identical units, is if this unit actually works, I can see what actually comes out of this while it's working, and then compare that to the signals I get from the tachometer on this other unit, and I can check the other points on the circuit boards at the same time. So I'm going to fit this working drive mechanism to the 2031-1541 that I'm currently working on, and we'll see if we have any more success with that. I didn't get any footage of me testing the tachometer coils of the two drive units, so I thought I'd go over the procedure and results here. I've got the schematic for the control board. That's on the rear of the unit, this board here. You can see the tachometer coil comes in here across this bridge rectifier. It's actually grey and yellow, not green and yellow. This is a typo in the schematic. And the rectified signal goes into the IC, this IC here, and then the IC decides how fast or slow to drive the motor based on the input it's getting from the tach. So to test the tach, I took the grey wire and the yellow wire. I've desoldered them from this unit because this is the failed unit, and tested the signal across with my multimeter in volts AC mode, and also tested the frequency the same way. With the failed unit, I was seeing about 660 Hertz and a signal amplitude of 280 millivolts. With the working unit, I was seeing 360 Hertz and an amplitude of 2.8 volts. Now you'd expect the frequency to be different because in the working unit the motor is being driven more slowly, so that the spindle motor goes around at 300 RPM. We're obviously seeing it going much faster than that in this failed unit. The key difference there is the amplitude of the signal that comes in. 2.8 volts for the working unit versus 280 millivolts for the failed unit. If we go back to the schematic, 280 millivolts isn't enough to get across the forward voltage drop of these diodes, which explains that the IC is seeing no signal on pin 1 at all, and therefore is just assuming the motor isn't going fast enough and driving it as fast as it possibly can. So I'm pretty confident that this tachometer is broken. I also tested the coil winding resistance and get 30 meg ohms, so that's open circuit. To keep this video moving forward and on track of getting the drive working again as a 2031, I've decided to temporarily replace this drive unit with the one I pillaged from a working 1541 drive. Then in a future video I'll hopefully come back and get this drive unit working again. I now have these 1541 internals of the 2031 disk drive working as expected, so I can turn my attention to converting this to a 2031. There are two things that are required to convert this to a 2031. The first is to add the IEEE 488 bus supporting circuitry. If you saw my last Floppies Rock video about the 2031, then you'll know that there are two additional chips required to drive the IEEE 488 bus, the 75160 and 75161. So we need to add that supporting circuitry. The second thing that we need to do is we need to replace the ROM, because this has a 1541 DOS ROM. We need to change it to have a 2031 ROM instead. The way I'm going to add the supporting circuitry is with this daughter board that I got hold of from Tynemouth Software. So this goes in place of one of the VIA chips on the board, and you reinsert the VIA chip in this daughter board, and it has 75160 and 75161 chips
installed within it, and then this is where we connect the IEEE 488 Centronics connector, and I think it's this 6522 that we replace with this. So I think it goes like this in the board, and then I will burn the appropriate ROM and install it in here. So I'll go away and do that, and the next thing you see, hopefully, we'll have a 2031 internals in this disk drive.
I finished making the modifications. Before we take a closer look, I thought we'd test it out. To test it out today, I have cracked out the Commodore PET. So first thing, I will turn on the PET. That's a good sign. We saw the 2031 reset, so there's clearly some connectivity between the drive and the PET. Next thing I'll do is run a simple basic program just to check the status of the drive, and if this works, it should give us a version string from the ROM installed on this drive. Right, let's run it. Excellent. So we can see that this has the stock 2031 ROM installed. Next thing we'll do is we will have a look at the 2031 LP test disk that I wrote last time. That all looks good. So let's do a performance test of this drive. Right, I'll put my scratch disk in. Excellent. I have a fully functional 2031. Let's take a closer look at the mod. Right, I have the drive in front of me, so let's take a closer look at the mods. If we take a look at this daughter board, first of all, I'll remove it from the motherboard and remove the connector. So you can see that everything's quite tight on here, nice efficient use of space to actually make it fit into pretty much the footprint of the two 6522s on the original motherboard. The fact that everything's very tight actually makes it reasonably difficult if you need to do some rework like I needed to do. I originally installed some header pins on here that would not go into any IC socket, so I needed to remove this socket up here and then remove the header pins and then put them all back. But I've done that, and it's still fully functional. I used a capacitor that sit quite proud, quite high up off the board, and that made it very difficult to remove these IEEE 488 driver chips, the 75160 and 75161s. That's not a problem if you use known good chips. I was using dodgy ones from AliExpress. Actually turned out to be fine, but I wanted to replace them at some point, and I needed to. It was very difficult around these two capacitors. You can see I bent this one over in order to get at the chips. So I've actually installed an extra socket in both to make them higher up off the board and easier to remove. There's a few passives on here, like a few resistors and a few diodes, but it's mainly just the IECs and then the connector that I've installed to go to the Commodore PET. Now, on the actual motherboard itself, I had to do a few things. First of all, I had to replace the IC socket for the 6522, because even these nice round header pins would not go in the one that had been installed, I think, at factory on this 1541 board. The second thing I had to do was install, there's actually two IC sockets here. There's a second one on top of the first, and that's to make it all sit just a little bit higher up so that these pins here don't foul against the other 6522. I also found the decoupling capacitors, both for the 6522 and these two ICs, fouled against the underside of this circuit board. I removed the 6522 one entirely because there's one on the daughter board here, and I've installed the two for these ICs on the underside of the PCB because there's enough space without fouling anything. So otherwise, not really happy with this. It does the job. It works. I'm a little bit worried about maybe heat build up of this 6522, but as I understand it, the chips tend not to overheat on these through their own the heat that they generate. They only tend to overheat if these voltage regulators get too hot, and in fact this 6522 should be shielded from that by this PCB. So we'll see. Second thing I'll talk about is the cable that I've used to go from this mod board over to the Centronics 24-pin connector, which is used by standard GPIP cables. This is what I started off with. I took a standard 24-pin ribbon cable, IDC connectors, cut one end off and soldered it to this PCB mount Centronics connector because that's all I've got. Now this is pretty sketchy. This will not stand the test of time. So I had an idea. I have these circuit boards. There's 3 boards here which go from the IEEE edge connector on the back of most pets to the same Centronics connector that we're looking at to allow you to use a standard GPIP cable. These I've had made and added on 1/10 of an inch spaced pin headers for debug purposes. I found that I could just about get an IDC connector and a Centronics connector on the motherboard. There's probably a millimeter too little space that are slightly bent, these 2 connectors, but it works just fine. It's fully functional, so I'm quite pleased with this as a solution. I don't yet know how I'll end up mounting this to the either PCB or the chassis. We'll come back to that probably in a future video. And then the ROMs. So there's 2 solutions for ROMs on this 2031 conversion. The first is to use stock 2031 ROMs, which means replacing both of them. The other is to install a patched top ROM. The process for producing the patch is a bit involved. You have to load the patch program onto a Commodore 64. You have to have the Commodore 64 connected to a stock 1541. The Commodore 64 then loads in the 1541 ROM from the 1541, patches it and stores it in memory. You then have to use a machine code monitor to write that out to disk, put it on the machine you want to write your EEPROM on, and then you're good. I've done that. I'll stick it on GitHub somewhere and put a link down below so other people don't have to go through that faff if they don't want to. I've actually got both variants installed here. I've got the stock top and bottom. I've also got the patched top and 1541 stock bottom on these ROM replacement chips here, and both work absolutely fine. What you saw before was the stock 2031 ROMs. If you use the patched version, you get a slightly different status when you first boot the drive. You get IEC-DOS rather than CBM-DOS. Otherwise, the drives seem to behave identically. These ROM replacements that I'm using here are ones that I've made using SST 39 SF010A EEPROMs, and I like these because they come in a TSOP form factor that's very, very small and allows you to stick with the original 2364 ROM chip sizing, so you don't end up going across the edges of the socket in your original motherboard. You do have to be proficient at surface mount soldering to get these installed, but if I can do it, anyone can do it with a bit of practice and a decent microscope. It's not that difficult. These are 1 megabit chips, so you can fit up to 16 different 8K images on these. Right now I've just got the 2 different 2031 variants on these ROMs. Now, final thing I want to talk about is the device number change headers on the mod board. So the way this is spec'd, and this is just based on an original design from a 1980s Commodore magazine published in Germany, I believe, is that you jumper both to get device 8. You remove this one for device 9, this one for device 10, and both for device 11. And there's a couple of diodes under here, one for each line, and that replicates the original 2031 schematic. I found that this works fine for device 8, device 9 and device 10, but if you remove both jumpers you get device 9 again. It's almost as if the ROM is noticing that this jumper is removed, deciding the device is set to should be set to device 9, and then doesn't even bother looking at this one. Now I'm quite dubious about that assumption, but I've examined this daughter board. I don't have any bridge traces, anything not soldered. I've checked the schematics of the original drive, the schematics of this, and I've toned everything out, and it really does seem to replicate the original 2031 schematic faithfully. And it's still refusing to operate as device 11. It always goes to device 9 when you remove both jumpers. So I took my Minty Fresh 2031 from the last episode, and I lifted both diodes, which is the documented procedure in a service manual for setting the drive to device 11, and I get device 9. So unless I'm doing something really stupid, which is always entirely possible, or there's a bug in the stock and patch 2031 device firmware. So if you know what I'm doing wrong, if you've got a 2031, you can set it to device 11 just fine. Please do comment below and help me clear up this confusion. Thank you. Alright, I hope you enjoyed this look at a 1541 disk drive installed in a 2031 case and my attempts to return it to its original 2031 roots. Obviously I'm not finished here yet. I need to figure out how to permanently mount the GPIP connector to the disk drive. I also would dearly love to get the original drive mechanism working again and reinstalled in this disk drive. It's sitting over there in pieces right now, waiting for me to fix it. Now, it may come across in a video that this was an easy and straightforward and quick process. In reality, it took me best part of a day to get everything sorted out. That's from actually performing the mod, coming back and correcting all of my mistakes, changing my mind about how the GPIP connector would be connected, going through the rigmarole of burning the different sorts of ROMs required for this disk drive. But I'm super stoked to have a second 2031 disk drive to add to my collection now. If you enjoyed this video, if you want to see more like it, please do consider subscribing. Until the next video, rock on.